Welcome everyone. In this video lecture, we will solve a numerical problem on GATE 2025 EC in which we have to determine the current flow along the length of copper wire of a circular cross section. Okay, so this one is a question from the GATE 2025 EC. So the actual question is an electric field of 0.01 volt per meter is applied along the length of a copper wire of circular cross section with diameter 1 mm. Okay, so in this question, the given thing is electric field value is given 0.01 volt per meter. Okay, is applied along the length of a copper wire having circular cross section. So what I am saying, there is a copper wire. Okay, clear? This one is a copper wire. Okay, and this copper wire having along the length of a copper wire of a circular cross section with a diameter 1 mm. So this diameter, we can say this diameter is given 1 mm. Okay, means the diameter of the copper wire, that is our, we can say this one is our d is given 1 millimeter. Okay, so we can say the radius will be just 1 mm by 2, or simply 1 by 2 mm, we can say the radius. Okay, 1 mm is the diameter. Okay, and along the length of the copper wire, so the length, we can say this length, I am assuming that this having length L. Okay, this one is a copper wire having length L and diameter, okay, 1 mm. Okay, clear? So the first thing, the given thing is our what? Electric field that we have written here. Okay, then after, the copper wire having cross sectional diameter is given, that is our 1 mm. So diameter is given 1 mm, so we can make it in radius, so like this. Okay, and the conductivity value is given this 5.8 into 10 to power 7. Okay, into 10 to power 7 Siemens per meter. So that we have to write first the value, you can say the conductivity. So conductivity is generally represented by the term sigma. Okay, sigma is for conductivity. Okay, this one is our electric field E, and this one is our diameter D, and this one is our sigma conductivity. So this value is given 5.8 into 10 to power 7. Okay, Siemens Siemens per meter. Okay, this one is the other parameter that is already given. Okay, so I am just highlighting. Okay, clear? This one, this parameter is given, that is our sigma. Okay, clear? Clear? So these are the parameters which are given. Okay, so we have to find the current I. Okay, so we have to find the current I. Okay, so we have to find the current I flowing through the copper wire. Okay, so we have to find the current I in the copper wire. Okay, so in general, if we have to find the value of current, so generally we have think about a resistor having length, having resistance R. Okay, and if there is some voltage V, so the corresponding current I can be written as I equals to V by R, or V, sometimes we can write as V equals to I by R. So generally we have to write I equals to, or always we are writing I equals to V by R. Okay, So that we have to write. Okay, clear? So the current in the copper wire is represented maybe in terms of voltage and some resistance. So one can write V by R. Okay. Now there is a relationship between this resistance. If length is given and cross sectional area is given, so the resistance value is written as R equals to rho L by A. This one is a very important formula. Okay, so that we have to remember. R equals to rho by L by A. Okay, okay. And one more formula that I want to, and these are very fundamental formula. Okay, and one formula, the electric field, you can say electric field is written as dv by dl, or sometimes we can write as v by l. Okay, this one is the another formula that I will use. So these two formula for resistance and electric field is written as v by l. Okay, so now we have to find the current. So what we can write, I value, as we have written, v by r. So in our question electric field is given. Okay, so and length is say l, so better to write this v by small l because we are using a small l. So the value of the voltage can be written as E times L, EL. Okay, or simply you can write E into L. Okay, E into L. And R value can be written as resistivity. This is nothing but simply resistivity. Resistivity. Okay, and L is the length and A is the area. Okay, so R equals to N, this should be L by A. So this L will be cancelled, and 1 by resistivity, suppose resistivity is say, so it is nothing but simply just the reciprocal of conductivity. So this can be written as E into A by rho. So simple. This 1 by rho is nothing but simply sigma E A. So the current expression first we have to write sigma E A, all in multiplication, sigma E A. This one is the important. Now everything is given, sigma value, E value and A value. Okay, so we have to start with the what value. So just we have to put the value. So okay, I am taking blue color. I, sigma value is given. So 5.8 into 10 to power 7. This is Siemens. Siemens is nothing but simply ohm inverse. Okay, so I am just writing unit also into E, electric field, volt per meter. So 0.01 volt per meter. Okay, these two. This value is our sigma, and this value is what we can say electric field, and the another value that we have to write is simply area. So area is nothing but simply pi r square, because this one is a cross sectional area, radius is given, so pi r square. So pi and r is nothing but simply 1 by 2, 1 by 2 mm, so 10 to power minus 3 meter whole square. Okay, so this can be written as pi by 4 times of 10 to power 6 meter square. So directly I can write this as a pi by 4 into 10 to the minus 6 meter s square. Okay, simple. This one is the area. So now here you can also see why I have written, this meter square, this meter and meter will be cancelled out. Siemens is ohm inverse. Now this one is our volt. Okay, so Siemens is ohm inverse and this one is some volt. Okay, so as we know V equals to I R. So if we write 1 by R, 1 by R, we can write it I by V. Okay, so this is basically why I am writing ohm inverse is nothing but simply I by what? V into V. So this will give the ampere unit, Siemens and volt. Okay, if this, so why I am writing, so Siemens into volt will be ampere. So no need to disturb Siemens volt. So if we solve, directly I am writing one line that this value, if we solve this 5.8 into 10 to the power 7 and 10 to the power minus 6, so it should be 10 into 0.01 into pi by 4. Okay, 10 to the power 7 and 10 to the power minus 6. So if we solve this one, okay, clear. So if we solve this one, it will nearly come, I have already calculated 0.46 ampere. Okay, so the I value will be simply 0.46 ampere, or we can write it A, or better to A. So the answer for this question, the current will be 0.46. Okay, so the right answer will be 0.46. The basic thing is that electric field is given, diameter is, so you have to write it radius 1 by 2 mm. Okay, so 1 by 2 mm is nothing but simply what? 1 by 2 into 10 power minus 3 meter. Okay, this was 10 minus 3 meter and sigma is so I V by R. So V E into L. We got dV by dL. So this one is also important. So these two or three fundamental formula that we have to know. Then pi r square area that we have used, and then after putting the relationship between the I, sigma, E and A will be the current, conductivity, E, the electric field into area. Okay, and R equals to rho L by A is also important. So we have finally derived the current value that is flowing through the copper wire having length L and cross sectional area 1 mm diameter. So the answer will be 0.46 ampere. Ampere is already given here, so no need to disturb. So directly options will be our simple 0.46. Okay, this is all about this numerical, and this is from GATE 2025 BC question. So thank you for watching this video. Thank you.